Okay, we'll start with the problem on the left, which is asking us to find the recursive rule to represent this situation, which is the amount of money owed on a loan increases by 18% each year. We're looking for the recursive rule. On the right, we're going to be looking for the explicit geometric rule. So we're looking for two different things here, but again, we're going to start on the left with the recursive rule. So, the recursive rule is just telling us, based on the previous step, how do we get the value for this step, okay? So what we need to look at here is that the amount of money owed on the loan increases by 18% each year. So we're going to take that 18% and we're going to figure out how we use that to get from one value to the next. So if it's increasing by 18%, that means we're multiplying by 1.18. The 0.18 part here is the 18%, and then the 1 is just the whole value of the loan already. So this takes the value of multiplying by 1, just keeps the value of the loan the same. But then if we add the 0.18, if we're multiplying by 0.18, that adds 18% onto the loan. That's the interest on the loan there. So if we multiply by 1.18, that'll tell us what the value of the loan is this year, based on how much I owed on the loan last year. If I didn't pay any of it and I had 18% interest, what's the value now? So if we want to write a recursive rule for that, it's going to look like a sub n, so the value of the loan any year. If I want to know that, I need to know the value of the loan during the previous year, which we don't know in this case, but we don't need to know that just to write the recursive rule. And we're going to multiply that by 0.18, our growth factor there. So that we're multiplying the value the previous year, which is the a sub n minus 1. We're multiplying that value by 1.18. That's going to tell us the value of the loan for the year that we're looking at. Because it increases by 18% each year. So that is our recursive rule. Now let's move on to the right-hand side here, where we're looking at the amount of money in a savings account, which increases by 5% each year. And we know the starting value this time is $330. Okay? So we are going to write an explicit geometric rule, and that's going to look something like, let's call this f of x this time. F of x equals our starting value of $330. We're starting with $330. And then it's increasing by 5% each year. So similar thing, that means we're multiplying by 1.05. The 0.05 is the decimal form of 5%. But we also still need to keep that 1, because if we just multiply by 0.05, it's going to get smaller. So we need to multiply by the whole 1.05 in order to keep the whole value that we have in the bank, and then add another 5% onto that. So going back to our formula that we're writing then, we have our starting value of 330. We're multiplying that by 1.05, and we're going to raise that to the power of x, because we're going to multiply by 1.05 every single year. So to find the value, say, of the bank account in 30 years, we would need to multiply that 330 by 1.05 30 times. So that's why this is an exponent up here.